Mathematics Applications and Interpretation, Paper 1, Timezone 1, HL, May 2025. This is question number 8, carries 7 marks. He has given us two functions, f of x and then g of x. F of x is a cubic function, g of x is a quadratic function. We have a domain for f of x, which is from 0 to 5. We have no domain for g of x. He says that the graph is crossing the x-axis. When the graph is crossing the x-axis, it basically means that the roots of the equation are 1, 5, and a. He wants us to find a value for a, which can be done using the graphic display calculator. We can also find the area from 0 to whatever this value is using the calculator again. And we can then use the calculator to equate these two areas. He says that the area under the curve of f of x from 1 to b is equal to the area under the curve for g of x from 1 to b. I need to find a value for b. All of these can be done using the calculator. So for part A, I'm going to write f of x is equal to 0, and I'm going to vaguely draw the diagram also, or the graph, for the examiner to know that this is what I did. Remember, I'm going to be drawing the graph only from 0 to 5. There's going to be a 1, 0, 3, 0, and this is a 5, 0. X-axis and y-axis. Therefore, the value for a is simply a 3, because I've already been given the value for a as 1 and 5, and therefore the remaining value has to be a 3. Using the GDC, find the area enclosed by the curve from 1 to 3. Let's go back and do that. I can shade this region. Next, we now need to find a value for b, and he says that the area under the curve of f of x and the area under the curve g of x is the same. So 1 to b f of x is equal to 1 to b g of x dx in both the sides. And here I'm supposed to be finding the value for b, right? I can use GDC again to solve this question. We're going to be using both the nsolve and the integration operator. Let me show that to you. So what basically happens here is that the equation has been solved and then the root has been given to you. Obviously, we know that the value of x cannot be a 1 because the lower limit is already 1. And therefore, I need to find other values for it. So what I'm going to do is to put a condition over here. Either you can go with this or you can continue to integrate the entire function manually, which is to find the integral of the function x cubed minus 9x squared plus 23x minus 15 dx, and equate that to the integral from integral of negative x squared minus 5x dx. You need to integrate both the sides from the value 1 to some value b, and then you will end up with a polynomial equation in b. You can take that and go to the graph and the graphical calculator and find the value for b. That is also fine. Make sure when you're writing the solution, just show the steps that you're doing on the calculator, like these steps. I've written here integral from 1 to b. This is what I wrote on the calculator, or even the graph, just to tell the examiner who is correcting your paper that, as to what you have done, like he should know what you have done. That's it for this video. Thank you.